my computer turned off. My battery just, I don't have a battery anymore, so when my computer gets unplugged, my laptop gets unplugged, literally entirely dies. I'm back, but I'm sorry. That sucks. It's fine. We'll just keep going. Okay, so what we're going to do. For j equals 0, j less than groups index I1 and I2 equals -1 equals -1. That will never happen, but groups dot length. What's a leetcode? Kark's Toxin is asking what a leetcode is. A leetcode is essentially there are these online problems that essentially they're like puzzles, and they're really popular for coding interviews. So they're used. So LeetCode is usually used. It's a website that's used for training, for like coding interviews. That's practically its entire purpose. And now we're solving a hard LeetCode problem. And this problem is a graph theory problem that is essentially if you have two characters on a graph that is connected by roads, bidirectional roads of three types, one where both of them can move on, one where only one can move on, and another one where the other one can move on. How many roads can you remove and still be able to traverse this graph? Everyone can traverse the graph. It's fully connected. And that is what we're trying to solve. And I have an idea. I have a solution that I have in mind, and I think we'll get it. It's again pretty easy. So what we want to do is edges I. And again, this thing, what I'm about to do is going to kill my complexity. I can already tell. I'm not happy about this complexity. But we do what we must do. If edges I1 is equal to groups J, now I want to do if, okay, yeah, no, this line here is going to kill her. Includes edges I1 I1 is equal to J. Oh wait, that's the issue. And we'll just repeat this. There's definitely a better way to do this, actually. I need to think about it, though. We're going to do this, and if it complains later about the efficiency, we can always backtrack and fix this port. I think this portion is going to be the one that's going to kill our effectiveness. If I1 not equal to I2, think it's concat. Is it dot dot dot? I think it's dot dot dot. I don't know if this is gonna work. I'm like fairly confident this is gonna work. Okay, let's try this and see what happens. The worst thing that happens is it does not work like I want it to work. And that is a result that I can live with. Wait, can I just do... I don't think it's gonna work, but let's give it a try. Okay, so we have a bug. Okay, why is it complaining? This is actually terrifying. That's a weird bug. I don't think it's gonna work the way I want it to work. Okay, scratch this. We're gonna do it differently. I'm gonna pick a slightly more iterative approach to this. What we're gonna do is we're gonna go through everything, until it reaches the end. Yeah, okay. Okay. We're going to skip this part because this part, I think, is what's killing us right now. And we're going to remove this. And what we're going to do instead is, actually, let's use a for loop. For let I equals 0, I less than edges dot length, and I edges I0 is equal to 3, and I plus plus. And now what we're going to do is we're going to iterate through this array. And when we're going to have found, we'll have something called found. And we're going to basically make this array called found. And we're going to make found have edges 0, 1 in it already. And we're going to have groups start at 1. Okay, that's it. And now what we're going to do is we're going to iterate. Also, we want to save the number of edges total. Total edges is equal to edges dot length. Okay, that should be enough data. We should be able to work from there. Because I want to be able to splice the edges out, and I need to know the total number of edges to actually work with that. Okay, so what we got to do is if found dot includes edges I 1 Okay, so what I want to do is if it's found, and actually I'm going to I hate this. We're going to want to loop through the entire thing multiple times. We're going to change this up. We're actually not going to iterate using the I, which is also, by the way, extremely horrifying. How are we going to do this then? 1 second. We want to iterate through it and find all of the ones connected. That's the first thing we want to do. And then after that, we want to go back through and redo it with the remaining portions until we get the groups. And every time we find a connection, we'll splice it out. I'm going to save the booleans actually. Because we're going to want to do a more interesting if statement for this. We're going to have to change the for loop. This is not accurate. I can already tell. I feel like I should just make this a while. The more I think about this, it makes more sense for it to be a while. So while the first edge is still a 3 type, and we're going to have an index. Okay, now we're in a good spot. Now we know what we're doing. If 1 and not 2, if 1 and not 2, then we're going to want to found dot push actually what we want to do first is if edges I 0 not equal to 3, I equals 0. Else all of this stuff. Because we want to return to the front if we're at a bad spot, and then we do the rest of this. So if edges I0 is 3, so it's a 3 type, then we're going to check this. And if it is a good edge and we're adding information to the array, we will splice it out. So we'll found.push edges I2. And then found or edges dot splice I. And then if 1, actually, we're across that, we're actually going to do this even more differently. Man, today's not my day. I'm just trying to make things happen. If 1 and 2, we'll do this first because that means we don't have to check. It's a minor efficiency thing. We don't have to check the Boolean twice. Let's go away. Whatever. So if 1 and 2, then we add an else here. Else if. Else if 2. And the last else is going to be if they're both false. So if they're both not included, edges splice I, found.push edges I2, I equals 0. So we're going back to the front if we found a good one. If 1 and 2, then we're going to just splice it out. Edges dot splice. And because we don't actually change anything, we can just continue onwards, and we won't actually have to increment I. And then this case is just a reverse, oops, daisy, reverse of this, and else I plus plus. Because if it's neither 1 nor 2, we're just going to skip past it for now. And this is actually wrong. Well, we want to go back to the beginning, but we also, at this point, found, if we get all the way to the end of the 3s, if I is less than edges dot length and edges I0 is not equal to 3. Actually, it's not less than. It's actually because we want to include a situation where it's not less than. So greater than or equal to edges dot length or edges I0 is not equal to 3. Yeah, those are 2 cases. And then found will be empty again. I will be 0. Because we're still within a situation where we still have 3 types. Edges dot length is greater than 0 and this. I0 and then groups plus plus. It gets worse. It gets worse. Every time I think I have a better solution, because we still need to check the interconnectivity of it after all is said and done. Because this is all fine and dandy, don't get me wrong. But I'm like in the think. I need to think really hard about this because okay, what we're gonna do is found dot unshift an array to the front of it. And okay. We're going to do this, and then we're going to do found 0 0. Edges 0, 1. Okay. Unshift, found 0, edges a splice. Found 0, edges a splice, found 0. And okay. Now theoretically speaking, this should work. What is the I need to see this work. What do you mean I? Okay. Sometimes JavaScript's console errors are ridiculous. Okay, I'm gonna actually use an individualized test case. And what I'm gonna do is we're gonna make two groups of 3, so 3, 1, 2, 3, 3, 4. It works. We're in. Okay. Now, the next thing we gotta do is it truly interconnected? And how we're gonna do that. So right now, we've already spliced out all the 3s. Everything left should be 1s and 2s. Hello, Two Rule. How's it going? My watch looks good. My arm. Yeah, I've had this watch for like 3 years. I have it on. Okay, I feel like on this stream specifically, I've been holding my head in my hand, just debating. I don't even know, like just trying to think. I don't want to check this edge case or just this test case. Okay, everything looks okay so far. So, what we want to do. So we have all of these. I just realized, okay, there's going to be some. Oh boy. So if no edge touches a point, that's an edge case. Honestly, we can just discount that immediately. Let's actually do that initially because that's a really easy way for us to just knock out an edge case. We're literally gonna just start off like this. For edges, for let I equals 0, I less than edges dot length I plus plus. And what we're gonna do is let's make initially an array. Is equal to array for let I equals 0, I less than n, I plus plus. ns dot push I plus 1. And then if ns dot includes actually we're going to do index ns dot index of edges I1 if index not equal to -1, ns dot splice first like. Thank you, 2rule. Actually, this isn't a good edge case to test for. Never mind. This isn't what we want to do. Because we still want to have ns here, but we're going to use it for something else. What we want to do is we want to add in every one that isn't in found. So we want to do, okay. So we've already used up I, don't need I anymore. So let I equals 0, I less than found dot length I plus plus, and then for let j equals 0, j less than found I dot length j plus plus if ns dot or index is equal to ns dot. Man, my brain is every second I'm doing this problem, it's going. It's more and more worse. Index of found I j, and then if, what am I doing? What am I typing? I don't even know anymore. If end not equal to -1, ns dot splice I, 1. Okay, so now we have an array of ns will just include everything that's not in the found arrays. So then for let I equals 0, I less than ns dot length I plus plus found dot push ns or NSI. Okay. So now we have, so run the code again. Let's console log found. Now we should have 4 in there as well. Yeah, okay, so that's all fine and dandy. So now we have all the found arrays properly made. Now what we want to do is we want to see if the found arrays are connected via the Okay, so here's how we're going to do this. We're basically going to do what we did before, but this time instead of us creating the arrays, we're just checking the arrays. So we just need to see if it's interconnected. That's all. For let I equals 1, I less than 3, I plus plus, so for A and B, for both people, for Alice and Bob, what we're going to do is index is equal to 0. And then we can pretty much just copy this code precisely. And also want to make for let j equals 0, j plus, or j less than found dot length j plus plus. Look equals empty array. Found, or not found. We want to do look and check is equal to another empty array. Look dot push j. Okay, so far so good. So now we'll have an array of all the possible found arrays, and ones we've already looked for and then checked, and then ones we've checked. Is equal to I. So what we want to do here is we're going to be going through this, and oh boy, sorry, I'm lost in thought. This is getting, again, out of hand very quickly. So if we still have stuff to look for, and if at the end so found dot unshift edges. Why did I do this? Wait. No, this doesn't matter. Index is equal to 0. Okay. So else, so if we still have, so we're not at the end and we still have stuff to go through. Then what we're going to do is we're going to go through the entire thing and we're going to start adding stuff. If I'm going to do same process before, 1 is equal to look dot includes edges wait. There's a better way to do this. There's a much better way of doing this. So we have an array full of the groups, right? We have the founds. So instead of doing it this way, this has a lot of like checks and stuff. We still want to do this, but instead of me doing this process here, which is going to be painful, let's do some pre-processing the data to actually make this work properly. So what we're going to do is for let I equals I less than n, I plus plus, I'm going to call it dict is equal, for dictionary is equal to this. Dict dot push 0. For let I equals 0, I less. Let's copy this code. J equals 0, J less than found, I. And here we'll just do dict found ij is equal to I. And with all that said and done, now we can do is one is going to be look.includes dict edges I, not I, end one, and just copy this here. 2 is going to be the same thing for 2. And again, we can just copy this logic because it's the same exact thing. Okay, so if 1 and 2, so if it's in both of them, or if they're in the same one. We'll just splice it. If it is if it's only in one, then we'll there's a better way of doing this. I think every single time I'm working on this problem, I'm always finding like better ways to do stuff. And it's both really, really good and really frustrating because I feel like I'm just going around in circles. We're making progress. I think we're so close because right now we already have all the numbers we need. Honestly, for the sake of just, I was about to say, well, no, let's just see what happens. You know, let's just run this and just see if we if it works. But no, that's probably shouldn't do that. We're already so close. Are you talking sequel? Um, don't think I should say your name, but person on Twitch. We're not quite doing if you are talking about SQL, we're not quite doing SQL right now. We're doing some JavaScript, but if you're talking JavaScript, I'm not aware of a union find in JavaScript. A graph algorithm. Probably. I'm not familiar about that name is not familiar to me, but I know quite a few graph algorithms. I'm just really bad at names. That's kind of my kryptonite. Literally ask me to memorize a process or an algorithm. I usually get it pretty quick, but if you ask me to remember its name, I will never get it. Pretty much a summary of my life right there. 1 second. So 1 edges I index 1 if 1 2 splice honestly we don't need check now that I think about it. We need look. We don't need look. We don't need to do this. We'll just do look is going to start with edge or dict edge index 1. And then what's going to happen is if index 2 is different, we'll splice it on. So if 2, we'll splice. Wait, is that wrong earlier? This is wrong. That is right. Yeah, okay. And then we're going to just repeat this for this one. And this is all pretty accurate. End, splice, end right here. End right here. Yeah, all these would be end. And then end plus plus. I'm so terrified that there's edge cases I haven't caught earlier on. And once we get to the end of this, I'm going to run it and it'll be like, oh, actually, that's not the right answer. And I'll be like, I don't even know where to start trying to fix this. That's probably a very possible result from all of this. Okay, so this thing here. Yeah, this is all accurate. So what we do is after we check it for one of them, which is going to be determined by this right here, for let j equals 0, j less than n, j plus plus. Actually, no, not n. Found dot length if cont is equal to true. And then all we're going to do is we're just going to do cont equals cont and look dot includes j. And if not cont, then return -1. And then so if this is true, return. Okay, we're basically at the very end. This is the last part of this. Total edges, return total edges minus groups plus n minus 2. Yeah. Minor bug. Edges. I'm confused. So dot length is greater than 0. Okay, we're on like the last I'm getting very, very quiet. I'm sorry about that. I'm not being a very good streamer right now, but we're kind of at the point where this is. Honestly, what we should do here is. Where is found determined? Where is look determined? Sorry, I'm just trying to like figure out where all these things I made. I'm going to start actually this with look is equal to empty, and then look dot push okay. Let's submit this. It worked. Wait. No, wrong answer. Man, I got so it was like it was buffering and I was like, is this it? Expected to. Okay, I'm gonna copy this test case first. We're gonna go back here. We're gonna enter the test case. Let's first see what's going on here. So our threes are right here. Actually, I already know where one of the bugs is going to be. What? Okay, we got an infinite loop somewhere now. Why? This is how do I get an infinite loop out of this? I minus minus I greater than 0. Do I manipulate I somewhere else here? No? Oh, that looks accurate. Oh, wait. Actually. Okay, so we have an infinite loop somewhere. That's phenomenal. Let's just, can I print this out and see what's happening? Let me see if it gets past the first case. Let me console log found, not found. We want to console log edges right now and see what's going on exactly. Okay, it all looks pretty good. So it doesn't get past 2. And this here is correct. So it's stuck between 0 and 1. And the question is why? Oh, wait. Still problematic, but I think we're getting a little bit closer, fortunately. Okay, this is all accurate. That's good. Edges.splice looks 0.push dictionary 0, 1. It's going back to 0. That means it's getting reset. So one of these must be happening. So if index is greater than or equal to edges.length and or edges in 0 is not equal to I. Is it getting triggered? Console. I probably should look back at what we're actually looking over as well. Yeah, so it's getting blocked at. Okay, actually, what I really should do here is instead of doing end, let's look at found. Not found, edges. We're so close. Okay. So there's a singular 1. let's do console.log. So 1 should happen. 1 should 100% happen. And 1 doesn't happen. Because of that, it'll just skip past it. Okay. I think I see what's happening here. So we want look, we want index. Look.push. We're so close. Literally, we're 3. So we're adding 3 to it. I will say there's an edge case here. I'm going to just add the edge case here. This should resolve the edge case. Then why is this false? Wait, why do I have this? Oh. Oh. Okay. We're getting somewhere now. We're getting actually somewhere. Okay, so why is this returning false? Oh, wait. Why am I doing it this way? Wait, is this correct? I'm like starting to lose the plot a little bit with this. Expected to. Oh, -1. So really it should be -3, really +3 minus. Okay, let's hope this works. It does not work. Oh boy, only 4 cases passed. Well, that's fun. Let's console log found. So we have 1, 2, 3. So 3, 3. Yes, this is 1, 2, 3, 4. Let's console log edges and see what happens. Okay, so all we have left is 2, 3, 4. So this that connects it 1, 3, 2, 4, and that connects it. So then with all that said and done, so this is all connected. This is 4 nodes in 2 groups. Um, 4 nodes in 2 groups. That should be 1, 2, 3, 4, 5, 6. So 6 total. 2, 3, 4, 5, 6. But they say the answer is wait, am I overthinking? No, it's for every single group. We need 1 path from each. So group -1 times 2. No, that's correct. So it's really 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But they say that the answer should be 2. Okay, so it's total edges. How's it only 4? Wait. 1, 2, 3, 4, 5, 6. So 3, 1, 2, 3, 2, 3. Okay, so I'm guessing the 3s are critical. So we need both of these. No, wait, no, it's 4. It is 4. It is 4. Okay, good, good. So it is total edges minus the number of groups. So the total number of edges needs to be groups, well, n, n minus 1, n minus 1 minus groups. Wait. If it's 2 groups, if it's 0, if it's 1 group, and is that it? Wait. Output 1, expected 2. Okay, I gotta actually write this down because my head is refusing to let me think rationally, apparently. So we have, let's say, 4 of these, and we have 1 group. So total number of them initially is n minus 1. Take groups into account. Each group we add into there, that is 1 chain off, so minus groups. So for instance, for 2 groups and 4. Wait, so for 4 minus, okay, it's n minus groups. So for 2 groups, it is 2. For 3 groups, it is 1. And let's say that we have 2 groups of 2, 1, 2, 4, 2, yeah. So n minus groups is the number of that. And then what we want to do is we need the number of connections between the groups. So that's going to be groups minus 1. So plus groups minus 1 times 2. Wait, no. It's found dot length. Let's finish this though. So this is going to end up being n plus groups minus 2 Okay, so this is an edge case. We found an edge case in this. So this edge, also, let's look at actually the details really fast. Not fantastic, being honest. I'm guessing what's happening here is it is trying to do this. If found is equal, actually, if not found dot length is equal to 1 and actually we can just skip this entirely. And just go here. If found.length is equal to 1 is not equal to 1. What's the edge case here? So 1, 2, 3, 4. 1, 3, 2, 4. That's correct. Why is this? One, one, okay. Yeah. How much time do I have, actually? I am tired. I'm not going to be able to go any further. It's already like past when I wanted to go to bed. I'm gonna call it. And actually, I streamed for much longer than I originally planned. We went to 2 hours, split across 2 streams because my computer died halfway through. I can't believe we didn't finish in 2 hours. Okay, I think we're close. I don't know what the bug is here. I have a feeling it's an edge case, or if not an edge case, it's like a small logical fallacy or logical error. I think it's hidden in this area here. I think all the issues are hidden in this section. This section here seems to work like a charm. It's this section that's gonna be a bit more painful. Well, technically, well, this thing here should also work. It's really just the algorithm I'm using to essentially show that it is a connected graph that is kicking my butt a little bit right now. I think we're really close here. Like, logically, everything that I'm doing so far makes sense. I don't know if for the bigger, like, how big can these things be? Um, yeah, I mean, looking at this, it is it's only 10 power 5. So it's not like, super fast. I feel like we have some stuff here that might we can simplify some stuff. I don't know how far we can simplify it. I do think once we get the bug solved, it'll all come together nicely. Anyhow, I am so tired. I hope you guys all enjoyed the stream. I hope you guys all. We didn't solve it. We didn't end up. Woo! I'll probably do when I wake up tomorrow before the deadline is over on this. I hope you guys enjoyed hearing me explain it. This was a hard lead code, so I know this is like definitely like on the higher end of like abstract thinking. At least for me, I was having trouble. Anyways, I don't want to bore you guys much longer with my rambling. Have a great night. Hope to see you tomorrow, and stay awesome. Hopefully tomorrow I'll fix everything. And tomorrow my day off, so tomorrow I should be better. That's all I'm saying. Anyhow, have a great one.